All right, we are starting 5.4. And so what I want you to do is go ahead and graph these first two. Let's go ahead and graph these first two and let's see what they look like. Of course, there's just two lines. So remember, this one is, we start on 4, like here. And this one we start on -1. So remember where you start. And then, of course, this one, the slope is this. So we move on this. This would be down and right. And that will work on this one. And this one would be also down and right. Okay, let's get that one done. Let's get this one done. And then we will see what is going on, and I'll help you with the answers, and then we'll actually write in our notes after this. So the nice thing, this is definitely a different section of the book. We finally moved on to 5.4. And so there's this section and one more section, that's the whole chapter. This section isn't as hard as the other sections. The next section isn't as hard as the other sections. We've done the meat of the chapter, we're just doing like the potatoes. Is that how that works? You know, the extra stuff, the sides, this is kind of a side. If you don't like potatoes, maybe macaroni and cheese. There's no dessert. You don't get a dessert with this meal. What would be the, I don't know what even a dessert would be. Yeah, maybe tomorrow's a dessert. We do get to color. Is that kind of like a dessert? I'm going to use this to color with tomorrow. It's going to be really exciting in yellow. So maybe that's like a lemon meringue pie. Okay, I'll stop. I went a little too far with that one. All right, I think this one goes here. I'm going to connect the dots. Shh.
I'm taking him for a minute.
All right, let's go ahead and look at this here. I think I got this. Okay, I did that one right, I think. Did I go down 2? Oh, I meant to go down 3. Well, that just is terrible. I'm glad you caught me on that. Because it wouldn't have worked out very well. I thought I went down 3. All right. I guess I had too much conversation about food and not enough about counting. All right. I don't know what to do with that. Let's move on to the next one. Let's see what the next one looks like. Okay, got 4 here. And this one is down 1, right 1. I'm just going to keep going. I could go up 1, left 1, 2. That one's easy. All right, this one, let's go down 2. And I'm supposed to go up 2, right 1. Okay. That worked out. Okay, so we see 2 different things here. This one's easy. What's the answer to this one? 2, 2. All right, let's go back to this one. What do we think is going to happen? They're parallel is what you say? Okay. What does that mean? They'll never cross? Well, how am I supposed to get an answer if they don't cross?
It's either undefined or I think it's 0.
You're close.
Oh, no solution.
No solution. Okay, we can tell they're parallel because they have the same slope, right? So that brings us to what we're doing today, and it is 5.4. Special systems. These are special because they don't necessarily do what the other ones do. So far what we've done is we got one solution every single time. Today, we are not getting one solution. Well, we will get one solution on some of the problems because not all of them can be special. Some of them are going to be normal. So we're going to have 2 different ones. So we just discussed parallel lines. And parallel lines are going to be no solution. Okay, now what I want you to figure out, and I'm going to draw one line. I want you to draw another line that we're going to have infinitely many solutions. Okay, so in this scenario, you get one solution because X marks the spot. In this scenario, you get no solutions. So how can I draw a line to get basically more than one solution? I want you to not say it out loud, and then I'm going to let you do it in a second. I want you to all try it and see if you can figure it out, and then I'll let you say it. Obviously, these 2 are going to be the special ones. This one is not special. It's the regular one. Okay, go for it. What do you think?
The lines are the exact same.
You're saying to like, so this is my yellow line. So if I have 2 lines that are the exact same line, then it's infinitely many solutions? Okay. And the reason why it's not all solutions or all real numbers is because it's points. And so it's every single point on the line is shared by both. But this point right here would not be a solution because it's not on the line. Okay, so sometimes it could be the same line. Okay, so what I'm going to do here is we're going to do some problems because I don't want to graph them every time. I want to be able to look at a problem and do it that way. So I'm going to write a problem down. And I want you to solve it. You already know how to solve it because that is not going to be new. All the things that we've already done so far are how we're going to do these problems. We just have some different answers. And so I want you to solve this problem right here and see what happens. Okay, probably what we need to do to the top line is what? Multiply by -2? Okay, I'm probably going to rewrite it just so we can get it done. So we got 4x minus 2y equals -6. All right, let me move it so we can see what I just did. All right, looks like I have it opposite. 4x minus 4x is what? 0? -2 plus 2 is what? -6 plus 6 is what? Okay. So I can't do any more work, can I? Everything eliminated itself. What does that mean?
No solution.
So that's the debate. Is it going to be no solution or infinitely many solutions? This is how I determine. Is this true?
Yeah.
0 does equal 0. So then it's not no solution, because no solution is going to be not true. This is true, and so basically 0 equals 0 is going to be infinitely many solutions. That means that this is the exact same line. Okay? If I were to written this in slope-intercept form, it would have been the exact same line. For example, this one would be y equals 2x plus 3. This one also is y equals 2x plus 3. Okay? You can check me if you want to, but it is true. So it is actually the same line. It didn't look like the same line, did it? Because there's some different numbers, but if you put it in the slope-intercept form, it would have been. Okay, so 0 equals 0. Let's do another problem and see what we think about that problem. And then I'm going to set you loose.
And this is all we're doing today, or?
This is all we're going to do on this Monday. And there's some things that I'm going to show you on it that might make it a little harder. But not really. So here's the next problem. Let's get straight-ish. Y equals 2x plus 1. Negative 2x plus y equals negative 5. Okay. So this is kind of the hitch that I'm going to throw into you, is we're going to start reviewing, obviously we've already reviewed graphing. This, you can do it substitution-wise, or you can do it elimination-wise. And even on the graphing one, on your final test, because we've already tested over graphing, if you hate graphing, you can kill the fraction and change it to substitution or to whatever you want it to change it, to solve it however you want. So I'm going to write this two ways. Here's substitution way. If I wanted to write it the other way, I would just have to move this guy over here. And that would be negative 2x plus y equals 1. Negative 2x plus y equals negative 5. Okay, so I'm going to work it both ways, just so you kind of remember which way you like it. That's the substitution way. Step 1 was isolate a variable, as already done for me. Step 2 was to put this here. I did that. Okay. On the elimination method, I'll finish it in a second. On the elimination method, it's lined up. All I have to do is this. Yep. So let's look at this. Negative 2 plus 2 is 0. Y plus negative y is 0. 1 plus 5 is 6. Okay, let me do this one also. Negative 2 plus 2x is 0. Okay, both of them are definitely broken answers. I know they're broken because the x and y are gone. Okay, does 0 equal 6? Does 1 equal 5? Okay. So that's what I'm adding. That's what I'm adding today. Don't want too much today. This is enough to get done. I want to go ahead and show you number 5 on here. And again, I'm going to suggest a method. I know substitution is an easy method. I know on this one, graphing is an easy method for these because it's in slope-intercept form. Do you have to graph them? No. You can do them any way you want to. You do have to show me. You do have to show me what method you're using. And I will easily be able to tell if you graph it because there'll be lines. If you use substitution or you use elimination, I will look at the work. So you can do substitution here. If you hate substitution, which some people do, Remember, you can just rewrite it like this. And I bet you that it won't be very hard to solve.